Okay, you should have already watched the video for Chapter 6 and worked the exercises, taken the online quiz. And again, because that's not a lot of information, but very important, you should all have that down and mastered. So now what we're going to do is move to the first of two parts to Chapter 7, which are called long truth tables. A truth table is a test for validity. And this is an idea you've seen earlier in the textbook, but we're finally going to be working with the notion of validity. Validity is a quality of an argument, and let me try to explain the basic idea here. A valid argument, remember an argument has premises and a conclusion. An argument that is valid is one where if the premises are true, then the conclusion must also be true. The classic example of a valid argument goes like this. I'm going to save that sheet. All men are mortal. This is a line from Aristotle. Socrates is a man. Therefore, Socrates is mortal. Premise, conclusion. If these two premises are true, then the conclusion must follow likewise. The validity is a feature of the structure of the argument, not about the particulars. We're not going to argue whether Socrates is my dog or not. That would change it, obviously, if it were, but that fact is something we're just throwing in as a premise. I'm going to give you another argument. Oh, who am I going to pick up? Let's see, Charlie Sheen. He's in the news. That's really going to date this little piece here. Okay, so what I've written here for argument 2, after getting the spelling fixed up a little bit, all cows are Hindus, Charlie Sheen is a cow, therefore Charlie Sheen is a Hindu. Now, this may sound crazy, but this is a valid argument. For the same reason this is a valid argument. The structure is such that if those premises are true, the conclusion must follow. If these premises were true, the conclusion would follow. The fact that not all cows are Hindus, as far as I know, they're agnostic, and that Charlie Sheen is not a cow, as far as I know, he's a human being, means that the facts here are incorrect. But if these facts were true, then the conclusion would follow. A valid argument is one where if the premises were true, then the conclusion would have to be true. So that's a valid argument, and that's a valid argument. It's just that one sounds crazy because the premises aren't true. Ultimately, since we're in symbolic logic, we're not even going to know what the premises are. The point for our truth tables, and we're going to be doing long truth tables here, is that we're going to be testing for validity. Now, not everything we do with a long truth table has to be to test for validity. There's another purpose to this. And I'm not trying to confuse you, but I'm going to show you this just to show you what a long truth table looks like. where we're going to use it to prove logical equivalence. That is to say, the two statements mean the same thing. I told you last video that not P and not Q are identical logically to not P or Q in parentheses. And how would you prove that? You would do that by the long truth table method. So what I would have to do is symbolize not P and not Q and symbolize not P or Q in parentheses and see if they match. So here's what I'm going to do. I'm going to set both of those up. And for the moment, just try to follow what I'm doing. I'm just looking for a slightly different color to work with here. See if this will come out. So I've got P and I've got Q. Remember the setup we used before, T, 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 F, F, T, F, F. Now to symbolize not P and not Q, I'm going to need three things. I'm going to need not P, I'm going to need not Q, and then I'm going to need not P and not Q. That's what I'll be looking for here. The other thing I'll need is P or Q and then not P or Q. So I start inside the parentheses, P or Q in the parentheses, and then I'll do not P or Q outside the parentheses. So let me talk you through what I'm doing here. True, 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 false, false, true, false, false. Not P is just the opposite of P. Now when I set this up, I said that P is T, T, F, F. Not P is F, F, T, T, just the opposite of P. Not Q is the opposite of Q. T, F, T, F becomes F, T, F, T. Now I have an and statement here, not P and not Q. Not P is on the left, not Q is on the right. The conjunction and, links them together. An and is only true when both parts of it are true. Do you remember that from chapter 6? An and is true when both parts are true. False and false is false. False and true is false. True and false is false. True and true is true. In other words, it's only true when both halves of it are true. Why? Because it's an and. Now we're going to do an or. An or statement we already know from last chapter. T, 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 F, F, T, F, F. An or statement is true when any part of it is true. T, T, T or T is true. T or F is true. F or T is true because some part of it at least is true. Only in line 4, false, false, is it false. So this should look familiar. P or Q, T, 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 F. Now the last step I'm going to do is negate P or Q. A little crump for space here. So if P or Q is T, 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 F, the negation is F, 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 T. I just take this thing that's in parentheses and I reverse it. T, 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 F, 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 T. And that's these two statements. So I have not P and not Q. The truth table for that is false, 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 true. I then have not P or Q. I reverse P or Q and get F, 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 T. These match identically. So these are logically equivalent statements. And if you remember from the last chapter, those are symbolizations of, can't spell today, neither nor. Okay? Now that's to show identity. That's not the main reason, and that's not anything I'm going to test you on, but the setup for these truth tables is important. A lot of this is not going to make much sense the first time I show it to you. You're going to have to do exercises and watch it and do exercises and watch it. I'm going to start you off with a really simple argument, and we will work from there to things that are a bit more complicated. So let's have this as our premise. A arrow B, conclusion A and B. The line here marks the difference between the premises and the conclusion. There's always one conclusion in an argument and any number of premises down to 1. So I have an argument here with one premise and one conclusion. I'm going to symbolize the A and the B, T, 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 F, F, T, F, F. If you were paying attention in the last chapter, you can do this. A arrow B is T, F, T, T. A and B is T, F, F, F. Okay, what I have above the line here is my premise. Everything below the line is my conclusion. To do a long truth table, I have to symbolize out the premises, and here there's only one, and the conclusion. So I'm going to label this P1 and label this as C. Premises, there's only one. Conclusion, there has to be one. So I have generated the long truth table for this problem already. Now what am I going to do about it? I go back to the argument about validity. A valid argument is one where, if the premises are true, then the conclusion must also be true. The way we're going to do a test for validity is this, and this is in your book a bunch of times. Step 1. Look for all true premises. Now, in this argument, there's only one premise. And so I look for every case in which the premise is true. Once I've done that, I check the conclusions. For lines with all true premises. The first time I do this, remember this is my conclusion. How do I know this is my conclusion? Because it says so up here, premise, conclusion. Premise, conclusion. Here I have a true premise and a true conclusion. I skip line 2 because the premise is false. In line 3, I have a true premise and a false conclusion. When I found a true premise with a true conclusion, I didn't stop. I kept looking. Once I found a true premise and a false conclusion, I am done. The argument is invalid. Right here in line 3. Why? Step 3. If true premises ever lead to a false conclusion, then the argument is invalid. Otherwise, it's valid. If true premises ever lead to a false conclusion, then the argument is invalid. Otherwise, it's a valid argument. Okay, this is in your book. True to false here in my premise to conclusions means that the argument is invalid and I'm done. If I never find that, if true premises always go to a true conclusion, then it's a valid argument. Because remember, once again, a valid argument is one where if the premises are true, then the conclusion must also be true. And it has to always be true. Let's try another one. This takes a little bit of getting used to. So, P or Q, Q or R, P or R. Okay? This is your first premise. This is your second premise. Everything above this line is a premise, and that's going to be your conclusion. P or Q is a premise. Q or R is a premise. P or R is the premise. Now, in the last few problems I've worked, I only had two different letters, A and B or P and Q or something like that. Here there's three letters, P, Q, and R. I can't symbolize all possible values for P, Q, and R using only 4 lines. I have to go to 8. And how do I know that number is 8? Because P can be true or false, that's 2 values. Q can be true or false, that's 2 values. R can be true or false, that's 2 values. 2 times 2 times 2 is 8. If I had 4 letters, it would be 16 lines. If I had 5 letters, it would be 32 lines. Now, it wasn't that tricky to generate all the values for true and false when I had 4 lines, but if you get up to 8, 16, and 32, you've got to be systematic about it. You can't just think about it. So here's how you're going to generate this. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to take these 8 lines, again, 2 times 2 times 2, 8. I'm going to cut them in half. For my first letter, and I'm always going to sort this alphabetically, I make the first half true and the second half false. 4 trues and 4 falses. I'm then going to take the number 4 and split it in half to 2. 2 trues, 2 falses, 2 trues, 2 falses. I'll take 2 and split it in half and come down to the number 1. And now it's just true and false alternating. What I've done here is I've generated all possible values for P, Q, and R, with P being true or false, Q being true or false, and R being true or false. 4 trues, 4 falses, 2 trues, 2 falses, 1 true, 1 false, alternating. Okay? That's the system I'm going to use. Now, there could be other ways to do that, but this allows me to grade it in a systematic manner. And it also helps you to not waste a lot of time thinking about something that's just mechanically producible. So premise 1 is P or Q. Premise 2, Q or R. Premise 3, P or R. P1, P2, C. So you want to mark your premises and mark your conclusions. Now at this point, if you thought of the OR rule as just TTTF from the last chapter, you're going to be lost because you've got 8 lines now. At this point, you have to know what the rule means. The rule OR means some part of this is true. Either the left is true or the right is true, or they're both true. So when I look at P or Q, P is on the left, these 4 T's and 4 F's. Q is on the right, 2 T's, 2 F's, 2 T's, 2 F's. And the rule of OR that I'm going to apply to these guys is this. If any part of it is true, then the whole thing is true. If any part of it is false, if both parts are false, only then is it false. True or true is true. True or true is true. True or false is true. True or false is true. False or true is true. False or true is true. It's only when I get to line 7, false or false, that the whole thing becomes false. In 7 and 8, false, 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 false means false, false for 7 and 8. So the symbolization of premise 1 is 6 trues and 2 falses. I do the same thing with Q or R. Q's on the left, R's on the right. True or true is true. True or false is true. False or true is true. False or false is false. True or true is true. True or false is true. False or true is true. False or false is false. So 3 trues and a false, 3 trues and a false is what Q or R looks like. The last thing is P or R, and I've got to look at P on this column and R on this column. T or T is T. T or F is T. T or T is T. T or F is T. F or T is T. F or F is F. F or T is T. F or F is F. I know listening to me go on about that is not the most exciting thing in the world, but I'm trying to explain to you what I'm doing here. Okay, now that I've got all this generated, I follow the test for validity. I have got a chart, the long truth table, with P or Q diagrammed, Q or R diagrammed, conclusion P or R diagrammed. And now I just have to read it. Remember the first step that we do when we're reading one of these to test for validity. I look and find all those places where I have all true premises. And where this is going to show up is in 1, 2, 3, skip 4, 5, and 6. 1, 2, 3, 5, and 6 have all true premises. True premises, true conclusion, keep looking. 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 In the last case, I have true premises and a false conclusion. That makes this an invalid, yep, you're dead, an invalid argument, because there is one place where true premises go to a false conclusion. Now, does it matter that 4 different times true premises gave me a true conclusion? No, it does not. The only thing that matters is there is a place where true premises give you a false conclusion, and that means that it's not a valid argument. So, this is what it is to set up a long truth table. And you should be able to operate at something like this level of complexity in order to take the final. It's a little tricky to write multiple choice questions about this stuff because you're doing charts. And so the question I'm often going to give you is, in what line is this valid or invalid? And in this case, you'd have to say in line 6, it became invalid. You would never say in line 1 it became valid, because valid just means you could not find any place where true premises went to a false conclusion. Let's do a little trickier one, and I'll just tell you in advance that this is a valid argument, so you know what this is going to look like. So, L or M, L implies N, M implies N, conclusion N. L or M, L implies N, M implies N, N. Okay? 3 letters, L, M, N. Now, the setup once again, there's 3 letters, 2 times 2 times 2. The number 2 is because they can be true or false. Means I've got 8 lines. This is a lot easier, by the way, to do on lined paper than it is when you're dealing with it free form on a chalkboard. I cut 8 in half, and I get 4 trues and 4 falses. I cut 4 in half, and I get 2 trues, 2 falses, 2 trues, 2 falses. And I cut in half, true, false, true, false, true, false. Okay? L or M, that's premise 1. L implies N, premise 2. M implies N, premise 3. Now my conclusion is just the letter N. The letter N has already been charted out for me here. I can just use that N that I've already got here and put it down here. Now some students like to copy the N over to the right, so you're reading left to right, but I'll just do it this way for a little bit of variety's sake. Premise 1, premise 2, premise 3, conclusion. Okay, premise 1, L or M. Here's L, here's M. And the rule is OR. An OR is true if any part of it is true. It is only false when both parts are false. Both parts are false in lines 7 and 8. So I'm going to go true 6 times, and then the last 2 get to be false. False, 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 false. L arrow N, L to N. I have to read this remembering that the rule is true arrow false, like in line 2, is false. Everything else is true. True to true is true. True to false is false. True to true is true. True to false is false. False to true is true. False to false is true. False to true is true. False to false is true. So TF, TF, and then 4 T's. Now, if that sounds kind of weird to you, you got to go back and really make sure you understand what the arrow means. M arrow N, true to true is true, true to false is false, false to true is true, false to false is true, true to true is true, true to false is false, false to true is true, false to false is true. And I did that pretty quickly, but again, it's only when true goes to false in lines 2 and 6 that the value here ends up being false. So I have diagrammed out my 3 premises, and here's my conclusion. Now, if I'm testing for validity, all three of the premises have to be true. In line 1, they're all true. In 2, nope. In line 3, they're good. 4, nope. 5, good. 6, nope. 7, nope. 8, nope. So there's only 3 of these that I'm going to actually be checking out, 1, 3, and 5. My conclusion over here is the letter N because of up here. So trues go to true here. Keep looking. Trues go to true here. Trues go to true here, and then I've got nothing else to check. If I cannot find a case where true premises lead to a false conclusion, then it is a valid argument. That, again, is basic long truth table. Now, there's one little gimmick here, and only one gimmick for this section of the material. P not PQ. This is a real simple version of this argument. So all I have are the letters P and Q. I'm back to 4 lines again. TT, TF, FT, FF. By the way, this follows the same pattern we just saw. 4 lines get cut into 2. 2 true, 2 false. 2 gets cut into 1. True, false, true, false. So I've got premise 1 here. Premise 2 is not P, and the conclusion is Q. Not P is the opposite of P. Excuse me. Yeehaw. So TTFF, FFTT. Now, how do I read this? I try to find places where I have all true premises, but I can't. I have no place with all true premises. Why do I end up with all true premises not happening? Because my premises are contradictory. And normally if I give this to you as a question, it'll be more complicated than just that. But I have contradictory premises, which means that they can never be all true. So I can never check to see what the conclusion is because there's nothing to check. Now, what do I do with that mess? A valid argument is one where if the premises are true, then the conclusion must also be true. But I can't make the premises true. If you go back to the test that we offered, if I cannot find a place, listen carefully, if I cannot find a place where true premises lead to a false conclusion, then it is a valid argument. In formal logic, an argument with contradictory premises is automatically a valid argument. So I don't have anything to circle here. All I can say is it's valid. I know that might sound a little bit bizarre, but that's just the nature of the beast. We'll do one more, and then I will leave you to work the problems in the textbook. Make sure before you try the second part of Chapter 7, these short truth tables, that you're really comfortable with the long truth tables. The more time you spend doing problems, even the same problems over and over again, the less difficult all of this is going to seem to you. Okay, this is real simple. X and Y, X or Z, negation Y or Z for the conclusion. So we've got X, Y, Z. Once again, this is going to take 8 lines. True, 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 false, 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 false. True, true, false, false. True, true, false, false. And then it just alternates. Okay? X or Y has to be symbolized. X and Y, excuse me. X or Z. And then not Y or Z. Now, I have to go inside the parentheses there, and then I have to negate it. When you're doing this, make sure that this intermediate step does not end up causing you any grief. That's why you label your premises and know that that's just a bookkeeping step you have to do. X and Y, it's only true when they're both true, which happens in lines 1 and 2, and the rest of it ends up being false. I'm a little off kilter here. X or Z is only false when both parts are false, so what I end up with is T, 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 F, T, F. X or Z is only going to be false in 6 and 8. 6 and 8 here. Y or Z, this is my intermediate step. This is only false when both parts of it are false. It's my intermediate step, which is in lines 4 and 8. T, 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 F, T, 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 F. Y or Z. Okay? Not Y or Z flips that. False, 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 true. False, 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 true. And there's your conclusion. There's your premises. So now I do the test for validity. I check for all true premises in 1 and 2, and that's it. I check my conclusion. My conclusion is false in line 1, and I'm done. It's an invalid argument. If I ever find true premises and a false conclusion, then I can simply shut down and say it's invalid and it doesn't matter what happens next. Okay, so this is what the long truth tables look like. You'll only be going up to an 8-line truth table for the test. When I do this in class, sometimes I give them a 16-line just to do it. It doesn't actually get that much more complicated as far as the intellect goes. It's just a lot more writing. But that's the premise, and that's the way this whole thing's going to have to go together. So like I said, do your problems with this. I would suggest that you copy down the problems I'm giving you now, and then maybe tomorrow after you look at the video, you go back and see if you can solve what I've already showed you how to solve. That's a really good learning step because the test questions aren't going to go crazy out of control. They're not going to be enormous monsters. Make sure you can do this. Now, this is not a question you'll have on your test, but make sure that if I give you that question, you can create the long truth table, you can evaluate it for validity, you can say, okay, now I've got it, I know that this is an invalid argument, and make sure that that matches up with what you learned yesterday. The more time you spend and the more of these problems you work, the easier this material is going to be for you. Okay, so for the moment, I am going to shut down, put my big the end sign, and we're going to go to the next tape, which is over Section 2 of Chapter 7.